So, next week is our Unit 3 test, our last test of the semester. Let's take a look at what's on there. Obviously, the annuity stuff from the last two classes is on there, everything we discussed today. We're also going to be going way back to simple interest. Now, one thing you'll need to make sure is you know the difference between ordinary and exact interest for simple interest. Also, make sure we can find missing pieces in the formula. Let me show you what I mean by that. So let's say that we are told a principal of $8,000 earns let's see, $80 interest in 90 days. Find the percent. So from that, we will have to I equals PRT. We know I, the amount of interest, is $80. Our principal is $8,000. Looking for the rate, and our time is 90 days. 90 over 360. It does not say otherwise, so we assume ordinary interest. So our first step here is going to be to combine 8,000 with the 90 over 360. So it'll be 8,000 times 90 divided by 360 is 2,000. And then we will divide by 2,000, which will give us 0.04 equals R. So that's 4%. And it may be one of the other components that's missing, either the time or the amount of the principal. Other things we'll need to be able to do. We'll need to be able to use the US rule for partial payments. So let's say that on May 5th, borrowed $5,000 at 7% for 60 days. On June 7th, paid $2,800. Find the outstanding balance at the end of the term. So May 5th, we originated the loan. The next action is on June 7th, which is what day? From May 5th to June 7th, that is 33 days. So we're going to find our interest before we do anything else. $5,000 times 0.07 times 33 over 360. $32.08 is our interest. So what that means is our balance before the payment is our $5,000 plus $32.08. So $5,032.08. And we subtract the $2,800 payment, $2,232.08. So our next action is at the end. There's a 60-day note. 30 days have gone by. 33 days have gone by. There's 27 days left. So our interest is that principal 2232.08 times still 7%, so 0.07. 27 out of 360. So $11.72. So that means 2232.08 plus 1172, $2,243.80 is the outstanding balance. Look familiar? I know I went through that pretty fast. Hopefully it's just review, and you can always look in the recording later if you need to. Any questions on that? Okay. Next. The simple discount note. We had the simple interest note, a simple discount note. Remember, is where we take out the money before. You take out the interest before they give you it. So your principal, the amount that you actually receive, is less than the face value of the note. So let's say you have a 90-day 8% simple discount note for $12,000. Find the proceeds and the effective rate. Remember, for a simple discount note, the effective rate's always higher than the stated rate because you don't get the full amount of the principal. So let's find the proceeds first. First, we're going to find the discount, which is the amount of interest. So 12,000 times 8% is 0.08. 90 over 360. Which is what? $240, am I correct? That's the discount. So that would make the proceeds $12,000 minus $240, or $11,760. That's the amount of money you actually receive from the bank for this loan. So for the effective rate, that's the number we're going to use. So we got $240 in interest. That's going to be our effective principal. It's $11,760. The rate now is what we're looking for the effective rate, and our time is still 90 out of 360. So we're going to do the 11,760 times 90 divided by 360, which is going to give us, what, $2,940, I believe? Something seems off there, doesn't it? No? That's right, 2,940 times R. Then we're going to divide by the 2940. So 240 divided by 2940. 0.08633. I'm at 240 and 2940. I dropped the 0 on both of them. Yeah. Nice catch, though. Yes, I did that intentionally just to save keystrokes. So that is 8.16% if you round to the nearest hundredth or 2 decimal places. On the test, if I don't tell you what to round to, go to 2 decimal places. If you go out to 7 or 8 decimal places, you're okay. I'll just charge you extra for grading it. So that is a simple discount note. Along with that is something called discounting a note. And this is where you have extended a note to someone else, but you want to get your money before the end of the term, so you sell the collection rights of that note to the bank. You basically take out a loan from the bank using that note as collateral. So let's say that on June 7th, you extend $7,000 90-day 6% note. On July 11th, you discount it to the bank at 10%. Find your proceeds. Okay, there are several steps here. The first step is to find the maturity value of the original note. So we have to find the interest. $7,000 principal, 6% is 0.06, 90 over 360, which ends up being what? Is that $105 interest? Somebody double check me there. $105, okay. So that means the maturity value then is the 7,000 plus the 105. So 7,105 is that maturity value. Step 2 is to find the discount period. Well, from June 7th to July 11th is 34 days. Remember, on page 396, you have that calendar table in the book if you need to look up the days to figure that out. But trust me when I say it's 34 days. Is that my discount period? Say no. Why not? Well, that's when we sold it to the bank. But the discount period, this is the number of days that have gone by. The discount period is the number of days that are left. That is the single most common mistake made on this next test, just so you know. So 90-day note minus 34 is 56 days. 11th to June 7th. You minus those to get 34 days gone by. And you subtract that from the term of the note to get the days left. That is your discount period, 56. So then we find our proceeds, where we have to first calculate the discount, which is going to be off the 7,105. The bank's rate is 10% and 56 days over 360. $110.52. So then the proceeds, you're going to take the $71.05 minus $110.52, which is going to give us $6,994.48. That's the proceeds. Any questions? So those are the main things from simple interest and simple discount notes. Next, you'll have compound interest. Need to be able to find both future and present value. The tricky piece there is effective rate. A couple of things to note on effective rate. Is the term. If the term is more than a year, what do you use to find the effective rate? 1 year. If the term is less than a year, what do you use to find the effective rate? The actual term. So, find the effective rate on $3,000 invested at 8%, 8% compounded quarterly. For 7 years. Do we care about the 7? The answer is yes, but very little. All that it tells us is that we're more than a year, so we're going to use 1 year. So our future value that we are concerned with is that 3,000 times 1 plus 0.08 divided by how many periods in a year? Quarterly. So 4. And to the power of how many periods in a year? Still 4. So 3,000 times 1 plus 0.08 divided by 4, close, power of 4. 3247.30. That's your future value. Now what we really want from that is the interest. So we're going to subtract our principal of $3,000. $247.30 in interest. So now for the effective rate, sometimes called the yield or APY, we're going to use that as the interest, $247.30 equals 3,000 is our principal, times the rate, times 1. Since it's more than a year, we're using the 1 year. So I'm not going to mess around with the 1. I'm just going to divide by 3,000. 247.3 divided by 3,000 is 0.08243. Is the rate. That's 8.24% is my effective rate. Make sense? If it is less than a year, let's say you invest $4,500 at 6% compounded monthly for 6 months. Find the effective rate. Well, we're going to start out by finding our interest again, finding our future value, I should say, not our interest. our future value is going to be that 4,500 times 1 plus 0.06 divided by, now does it matter here that it's less than a year? Not in this point it does. It's still compounded monthly. We're going to divide by 12. Because the 6% is still annual, it still gets divided up by 12 months. Where the less than a year matters is in our power here. Because it's not going to be the power of 12 because it doesn't go for a full year. It's only going to be for 6 months. So it's going to be how many periods? Monthly for 6 months is 6 periods. 4,500 times 1 plus 0.06 divided by 12. Power of 6. So that's a little bit confusing. Here we still use the full 12 because we're dividing our rate to get our rate per period. For the power, though, we only use 6 months because that's the number of periods that we have. 46, 36, 70. It's our future value, and we will subtract the original 4,500. Get $136.70 is our interest. So now our effective rate, 136.70 equals 4,500 times R times 6 months is 6/12 of a year. We combine our 4,500 and 6/12 will give us 2,250 times R, and we divide by 2,250. .060756. So 6.08 it looks like percent. What do you think? That brings us up to all of our annuity stuff that we've covered in the last 2 classes. This is one of those tests that takes a while to do. You just got to take your time and figure out first what formula we're using. Is it just a compound interest formula like this, or is it one of the long annuity formulas we were doing in the first 2 hours? Or is it just the simple interest? So that's the biggest thing the advice I can give you is take your time and make sure you know you're using the right formula.
I don't suppose you allow just